Good afternoon, everyone. Thank you for joining us. Welcome back, and we're glad that you're here. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, the Science and Technology channel.
Yep, and we were talking about space once again. Imagine that, huh? Here we go. This is a cool story. This is kind of weird, actually.
It's cool what these telescopes are picking up. Astronomers have observed a sun-like star dim dramatically for 9 months after being obscured by a vast cloud of gas and dust. So when they say sun-like, it must be like our sun, same size, right? Brightness, maybe age, I don't know. A huge cloud filled with vaporized metals has been spotted blowing powerful winds, and it temporarily blocked the star's light for almost 9 months. The observations that were made, thank goodness it wasn't our sun. The observations were made with the Gemini South telescope in Chile, one half of the International Gemini Observatory, partly funded by the U.S. National Science Foundation and operated by the NSF NOIRLab. Researchers say the event provides an unusual look at the restless, messy activity that can keep reshaping planetary systems long after they form. Would you like to know more?
All I got to say is they better cut out some of those fireplaces up there. Too much gas, too much vapor. All right, the story began in September 2024 when a star about 3,000 light years away abruptly faded to about 1/40th of its normal brightness.
That's weird.
It is weird. It stayed that dim until May of last year, 2025. The star J0705 plus 0612 resembles our sun, which is why its sudden drop stood out to Johns Hopkins University astrophysicist Nadia Zakomska. Quote, stars like the sun don't just stop shining for no reason, she says. So dramatic dimming events like this are very rare. And I would think kind of alarming, I would think, right? What if this happened to our sun?
I was just thinking the same thing.
We'd be in deep doo-doo if that happened.
Crops would fail, right?
Yeah.
And that means animals wouldn't be eating. Humans would be eating meat, so a lot of animals would be dying.
Yeah, so throw solar out the door, right?
Right. So this is we'd have to go back to coal and natural gas and nuclear.
And a lot of jack.
This is crazy. If this happened here, crazy. Because the dimming lasted for months, Zakomska's team organized follow-up observations across several major facilities. They used the Gemini South telescope on Cerro Pachon in Chile, along with the Apache Point Observatory 3.5-meter telescope and the 6.5-meter Magellan telescopes. The results are reported in a paper appearing in the Astronomical Journal on January 21st, 2026. Combining
these new measurements with the archival data on J0705 plus 0612, the researchers concluded that the star was occulted, meaning a large, slow-moving cloud of gas and dust passed in front of it and partially blocked its light. So it really didn't go dim, it just was shaded, right?
Shaded, yeah.
Their estimate places the cloud about 2 billion kilometers, 1.2 billion miles for you Yanks, from the star, with a span of roughly 200 million kilometers, 120 million miles.
Wow, that's huge.
That is huge.
The evidence suggests the cloud is not drifting freely. Instead, it appears to be held together by gravity and linked to a secondary object orbiting the star far from the center of the planetary system. The companion has not yet been identified, but it must be heavy enough to keep such a large cloud bound. Based on the observations, it is at least a few times the mass of Jupiter, and it could be larger. The possibilities include a planet, a brown dwarf, or an extremely low-mass star.
Just goes to show you, there's worlds beyond these, right?
Yeah, crazy. Yeah.
If the unseen object turns out to be a star, the cloud would be classified as a circumsecondary disk, meaning a debris disk orbiting the small member of the binary system. If it is a planet, the structure would be circumplanetary disk. Either way, catching a star being occulted by a disk that surrounds a secondary object is extremely uncommon, with only a handful of known cases. Wow.
To find out what the cloud is made of, the team relied on Gemini South's advanced spectrograph, the Gemini High-Res Optical Spectrograph, also called GHOST. In March 2025, GHOST observed the occultation for a little more than 2 hours, splitting the star's light into a spectrum that reveals which chemical elements are present in the material between the star and Earth.
Quote, when I started observing the occultation with spectroscopy, I was hoping to unveil something about the chemical composition of the cloud, as no such measurements had been done before. But the result exceeded all my expectations, says Zakomska.
The GHOST data revealed multiple metals, elements heavier than helium within the cloud. More remarkably, the high precision of the spectra allowed the team to directly measure how the gas is moving in 3 dimensions. This marks the first time astronomers have measured the internal gas motions of a disk orbiting a secondary object such as a planet or low-mass star. The observations show a dynamic environment with winds of gaseous metals, including iron and calcium.
The precise measurements of the speed and direction of the wind show that the cloud is, moving separate from its host star. This, combined with how long the occultation lasted, further confirm that the occulter is a disk around a secondary object and that it orbits in the outer reaches of its host star's stellar system.
This is fascinating. Like winds in space. I just didn't know that existed. That's crazy. You know what I'm saying?
Yeah. What creates that?
I know. I mean, maybe the heat and the solar flares from a star.
Yeah, or maybe
pushing it.
Black hole flatulence. I don't know. Who knows? Where does it come from?
The source shows infrared excess, typically associated with disks around young stars. However, J075 plus 612 is more than 2 billion years old, meaning the disk is unlikely to be leftover debris from the system's early planet formation. So how did it form?
Zakomska proposes that it originated after 2 planets collided with each other in the outer reaches of this star's planetary system, ejecting dust, rocks, and debris and forming the massive cloud now seen passing in front of the star. Okay, there you have it.
So they got pulverized. And that stuff stick together. That sounds reasonable.
So when 2 planets collide, does it make a noise?
Well, yeah. Will you notice it in the forest?
Right.
Yeah. The discovery highlights how new technology enables new insights into the universe. GHOST has opened a new window into studying hidden phenomena in distant star systems, and the findings provide valuable clues about the long-term evolution of planetary systems and how disks can form around old stars. Who knows? Eventually, that will form back into a planet. Who knows? In a couple zillion years.
Well, as normal, I learned something every time we do one of these segments. This is pretty cool stuff.
Really cool.
I don't know if I would ever. If somebody said, "Hey, you want to study this for the rest of your life?" I probably wouldn't have gone into that room, but somebody did, and this is cool information that we're getting.
I wonder if there's an organization that's coordinating all the telescopes around the world. So, okay, we got something going on over here. Let's use these different telescopes to get different data, and then we'll piece it together. I wonder if there's anything like that.
I don't know, but it sounds like they should be doing that, Yeah, because we've got some really, as we've talked about, we've got some really amazing, powerful telescopes and ways to look into deep space. And this is deep, right? We're talking way past Pluto.
3,000 light years. You're preaching to the choir, man. Preach on, brother.
Yeah. So this is cool stuff. Yeah.
All right, folks. Thanks for joining us. We hope you enjoyed this segment.
See you tomorrow. Take care. Thanks.